Hello! Ah, I still don't have the energy. I still have some cold inside me, so let's not go high energy. But I am very happy because I am feeling better. So I can say hello. Okay, this much. Jeez, alright. Let's restart. Let's start from the beginning. By the way, books are amazing. The 5 people you meet in heaven. I guess I'm not one of them. So I am feeling better. Let's get an update. I'm feeling better. Last night I woke up in the middle of the night, but I didn't have any like sore throat or earache. I just had coughs. Speaking of devil, but I feel I'm better. I went to doctor by the way yesterday. He said, no dude, you have no inflation, no inflammation. It is not antibiotic or biotic or bacteria or whatever. I feel it is just happening every year now. First time it was crazy. It was I guess 2 years ago when we went for the RV trip with guys to Montana. I like the whole trip, like second half of trip, I was like dead. And at that time, like COVID was such a big deal. We were guessing. I think last year also, like, during this late August, early September, I got something similar, and this year, so it's something happening again and again. It's too hot. Yeah. And let's see. I guess it's not COVID. And by the way, the doctor told me for $5 you can go get a COVID test. Now they charge you for the COVID test. So I didn't go. And it seemed like nobody cared. Like, doctor was like, oh, you may have COVID. And like, no distance, no anything. If you like, you can go check. But like, nobody takes it seriously. Woo! Well, that's a good thing, by the way. We got rid of it. Everything was closed. COVID was 3 years ago. I guess 3 years ago, right? Yeah. So done. COVID done. Let me go turn on the lights. Still, I feel I need to turn the AC on because I think the main reason that made me sick was that you go to Z Center and the AC there is not on and the weather changes here fast, so I felt I sweated a lot and then I went outside, the weather was cold, something like that was the reason. Let me also check if this setup works. Yeah, it works. And what else? I'm thinking of doing the Airbnb. Yeah, let's go study Airbnb. 11 authors, 8 pages. Where are you, Airbnb? Thesis. That's it, that's here. Airbnb. Yeah, for sure we need a Spotify, Speechify. Give me a second. Nothing fixes me like hot water, to be honest. And fruit. I felt every time I had a strawberry, I was feeling better. Shit. All right. Jeez. Speechify. Go to the web app. What is that one? La 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 la. Yeah, come here. So after this we will go fix the notations and tell Ehsan that we updated the notes, and let's see what's up. So we have 5 here. I have to delete some of them. Min Chen, thank you for diversifying. And delete. Where is it? Delete. Yes, confirm. And I better talk not much. Let's get healthy, completely healthy. Then we start talking. Then, yeah, that's exactly what I need to do. I don't need to be high energy right now. Just let's play it safe for 2 more days, 2 more days, and we will come back. We have time. Where is it?
Learning to rank for maps at Airbnb. Malay Huldar, Hung Wei John, Kedar Beller, Sherry Chen, Soumyati Banerjee, Xiaotang Wan.
So it's 8 pages.
Mustafa Abdul, Huiji Gao, Pavan
11
Tapadaya,
writers.
Liwei He, Sanjeev Kataria.
You can see the change.
Airbnb Incorporated San Francisco CA, USA. Malay.huldar at airbnb.com. Abstract. AR 142407.00091.
I love to invite them for a podcast. We have a podcast here. Why don't you join us? Dude, I should do that. That's actually amazing. Let's do it. Let's do it and see. Actually, today morning I was thinking, like, inviting Amin just to present one of his works. Why not? Let's do it. Like, he comes and talks about one of his short papers or ideas. Dude, I should delete this shit. Sounds weird. And we can check how armchair of a theorist, how theorist of an armchair Amin is. Oh my god, this is good. Alright.
Abstract.
I will invite
AR1424OC. Abstract. As a two-sided marketplace, Airbnb brings together hosts who own listings for rent with prospective guests from around the globe. Results from a guest search for listings are displayed primarily through two interfaces. One, as a list of rectangular cards that contain on them the listing image, price, rating, and other details, referred to as list results. 2, as oval pins on a map showing the listing price.
List results. Okay, that's how Airbnb works. So, long time now I'm arranging. Today I will do it. Every one of these things people are making videos. Interesting.
Called map results. Both these interfaces, since their inception, have used the same ranking algorithm.
So what is it? These are displayed through two interfaces. As a list of rectangular cards that contain on them the list image, price, rating, and other details. It's a list result, it's not on the map. As oval pins, this is the, of the map. Map result. Both these interfaces, since their inceptions, have used the same ranking algorithm. By booking, they are saying that we rank them based on your booking probability and selects the top listing for display. What does that mean?
Orders listings by their book ing probabilities and selects the top listings for display. But some of the basic assumptions underlying ranking
So orders
built for
by
a
the
world
booking probability and selects the top listing for display. Top listing, popularity.
where search results are presented as lists, simply break down for maps. This paper describes how we rebuilt ranking for maps by revising the mathematical foundations of how users interact with search results. Our iterative and experiment-driven approach led us through
So look
a
at
path
the
full of
trade-off.
twists and turns,
When we go on the
ending
list, or what is it called? List result, you can see the house price, number of rooms, like the place description, in photos, everything. The map, the good thing is that you can see the price, and to be honest, it's not a it's not like a ordered list. It's just a two-dimensional. You see the location, so you can see all of them at one time, right? There is no forcing your attention to look at one part. The bad thing is that you cannot find if the rooms are good, bad. So there is trade-off on how they present information.
in a unified theory for the two interfaces. Our journey shows how assumptions taken for granted when designing machine learning algorithms may not apply equally across all user interfaces, and how they can be adapted. The net impact was one of the largest improvements in user experience for Airbnb, which we discuss as a series of experimental validations. CCS concepts, retrieval models and ranking, rightward arrow learning to rank, human-centered computing, rightward arrow graphical user interfaces, electronic commerce, rightward arrow online shopping. Keywords: search ranking, map search, e-commerce. 1. Introduction. As of June 1st, 2024, there are more than 7.7 million active Airbnb listings in over 100,000 cities and towns worldwide. The total number of guest arrivals, contributed by guests all across the world, now exceeds 1.5 billion. The vast majority of these guest arrivals started with a surge, the core mechanism that connects
1.5 billion.
guests to hosts.
This is
What makes Airbnb search a particularly strong?
like, you think it is easy. We have this two-sided online marketplace, but they are actually massive engineering achievements. $1.5 billion. That's crazy. Well, it's not just engineering, but it's crazy. Let me see. One thing I wanna do is, but this is too hot. Yeah, I wanna send an email to the writer. Well, we can send the email once we finish it. But I wanna get into contact with all these people.
Case for machine learning application.
Holder. Okay, I have to pause. Yeah, let's see how it goes.
Is its global scale, coupled with the individuality of each listing. Every listing has its unique location, along with its own look and feel. Furthermore, even the most popular listing can only be booked a maximum of 365 days in
That's the nice
a year, so memorizing
constraint that Airbnb has. We have this like inventory constraint that is very strict and very present. On Amazon, on Google, on Amazon, on eBay, you may say, okay, the company or the seller has a big inventory and it's not going out of stock right away. But in Airbnb, once you get a room, it's done.
Top results and replaying them back is not an option. Airbnb search demands a truly generalized learning of what each listing is offering. And true to expectations, artificial intelligence shines on this occasion, far surpassing what human intelligence can achieve. As part of an evaluation exercise, ranking engineers were shown peers.
AI is getting better than
Figure 1, search box with destination, check dash.
Stop. Surpassing what human intelligence can achieve as part of an evaluation exercise, ranking engineers were shown pairs. So look at figure 2, search results as mappings, and then we have the card. And
of listings and asked to identify which listing out of the pair was booked by a searcher. The ranking model correctly identified the booked listing 88% of the time, while ranking engineers could man-dash age only 70%.
What is it? 80%? Far surpassing what you can achieve as part of an evaluation exercise, ranking engineers were shown pairs of listing and asked to pairs of listing means card and map to identify which listing out of the pair was booked by a searcher. What is the pair? Listing over 100,000 cities and town worldwide, the total number of guest arrivals all across the world now exceeds 1.5 billion, which is crazy. We have 10 billion people. What is it? The vast majority of these guest arrivals started with a search. the core mechanism that connects guests to hosts, and what makes Airbnb search a particular restaurant. Machine learning is its global scale coupled with the individuality of each listing. Every listing has its unique location. Location, that is what's super different. We don't have map, we don't have location on Amazon or eBay. So it's an added dimension. Getting out of stock, another constraint in very active in Airbnb. With its own look and feel. Furthermore, even the most popular listing can only be moved. Yeah, so memorizing top results and replaying them back. This is what others do, right? I think it's also true for dating apps. Like 365 times 4 a day, I don't know. But so it cannot show the most popular room all the time. And back is not an option. These things gets out of, but eBay or Amazon can't do that. Airbnb search demands a truly generalized learning of what each listing is offering. And true to expectations, artificial intelligence shines on this occasion, far surpassing what human intelligence can achieve. As what is this experiment? Okay, I think we should go further. But as part of an evaluation exercise, ranking engineers were shown pairs of listings. And what is the pairs of listings? And they were engineers. Well, of course. Oh, okay, ranking engineers. All right. And asked to identify which listing out of the pair was booked by a searcher. What do you mean? Okay. So they show you two cards, for example. I don't think it is a map next to a card. They show you two cards, the engineer, and say which one of them is chosen. And engineer's rate was 70, which is pretty good. And machine model was 88%, 18% more. So I don't know why this is interesting. Interesting. Okay. That is interesting because that is actually what makes Airbnb unique, because on one side they need to put the popular ones on the top so consumer have a better experience. On the other side, they cannot show a building all the time. So it seems in Airbnb they came up with a model that predicts users' behavior and says, okay, between these two cards, users are more interested in this room other than this one. Because they need to have a prediction of user behavior so that they can update their list online faster. Maybe on Amazon, maybe on eBay, they don't need to come up with a prediction for user behavior, user model. Because they say that, okay, whatever is on the top, let it be on the top, it's a popular one, and they won't go out of stock for most of the time, so we can keep showing them. This is super interesting. But okay, this part is nothing about maps. This is just about, even if it was just a listing algorithm, presentation to the consumers, it was the problem. Map thing haven't been involved yet.
This level of performance wasn't achieved overnight. The launch of our first neural network model is described in 10, and its Avo Lotion is captured by 11, 1, 16, and 9.
Interesting.
The ranking tech stack described in these publications powers searches from two sources. First is the familiar search box, where a destination location, check-in/checkout dates, and guest counts are entered explicitly by the searcher, figure 1.
Yeah.
Results from the search can be accessed as list results, figure 3, and map results.
Their figure 1 is here, come on, you should do a better presentation. Alright.
Figure 2. The user can then point the map to an area, and the latitude and longitude boundaries of the map serve as a second source of searches with implicit query parameters. Overall, the search box generates 20% of searches, the rest coming from maps.
Wait, what? Okay, that's important.
The main
These
goal-
numbers give you very good intuition. The user can then point the map to an era, and the latitude and longitude boundaries of the map serve as a second source of searches with implicit query parameters. Overall, the search box generates 20% of the search, the rest coming from the map. So 80% of them, people go on the maps. That's a big thing.
Of these interfaces is to maximize the number of bookings, the key measure of success both from the guest and the host perspective. To
So
achieve
it's
this
like,
goal,
look, they're
listings
saying we want to maximize the number of bookings, not necessarily the booking that generates a good experience. But in long run, you may say, okay, I want to give them a good booking so they keep coming back to. Is again fairness.
are sorted by their booking probabilities, and the top listings are selected for display as cards in a list and as map pins. The algorithm works by ensuring that the higher the booking probability of a listing, the more attention it receives from users. A formal analysis is
But
presented.
it is also a self-fulfilling prophecy. That's the thing. We talked about it. So you have a list. Let's consider. Well, we have the probability again here too. We know that the top of the list gets more probability of booking. All right, at least in short term. So you will have a curve like this. If you change the order of your houses, you again will have a decreasing curve. So how do you know which decreasing? How sharp do you want to have the drop? Is it the best, or you want a more smooth curve? I say you wanna, I don't know.
Figure 3, search results as list
Just
of
here, because here we can actually assume that we are in the space of decreasing function. And the question is, what is the better decreasing probability density function? Wait, figure for x-axis search rank for list results, y-axis normalized click-through rate, which is kind of probability density. And in section 3, what is section 3? Section 3 of 9, the algorithm remained the status quo for many years, but as it happens, disruption come unannounced. Alright. Figure 5, x-axis search ranking for the list result and map results, y-axis. What does it mean to have a rank for the map result? On the map, you are just unless you say you should zoom in, normalized click-through rate. Alright. Again, you can see that there is this decreasing function. Which one is red? Oh, red is map, which we can see is the decay is slower. Oh yeah, actually that's true. And list result is sharper because you force people's attention to the top of the list. I agree. And then it says expected for map results, which is kind of a constant curve, which I agree because it's two-dimensional. How can you, I mean, I don't know what rank means. Rank is a one-dimensional thing. So you cannot have an order on a map. That's what I'm saying. That's the topology itself. Map is not equal to list. Let's go over it.
normalized discounted cumulative gain, NDCG, is our de facto tool for evaluating ranking. To understand ranking performance in Vari-US settings, we look at NDCG for that query segment. Comparing the NDCG for queries from the search box against the NDCG for map-generated queries uncovers a stubborn gap of 2%. For many years, engineers suspected the tech stack powering search through maps ought to include something unique to the interface itself.
Dude, it's just
But
your
this
reading
mostly
is so
drove
bad,
feature-
I don't want to read you. But this mostly drove features engineering focus on maps, distance of the listing from the map center. Okay. They were saying the attention is from the center of the map and it decreases once we go to the corners. For many years, engineers suspected that is actually a good idea when you look at it says how a human being behaves once they look at a two-dimensional map thing, where they put their attentions. For many years, engineers suspected the tech stack powering search through maps ought to include something unique to the interface itself. We mostly drove feature engineering focus on maps, such as distance of the listing from the map center. The general wisdom was that as long as all the necessary features were supplied to the model, it would do the right thing. There wasn't much to explore behind. Okay. Although map search interfaces are used by billions every day, okay, I cannot keep reading. What if I just...
Although map search interfaces are used by billions every day, there is little mention of how to customize search for maps in the machine learning literature. To the best of our knowledge, there are some references from the early days of the internet, like 19, but there seems to be no research trail for the last 20 years. Discussion of ranking for products similar to Airbnb, 14, 4, 17, gives no special consideration to maps. This lack of prior publications further supports the thinking that map search is nothing special. And yet, we have hints that searching using maps leads to a different user behavior. To shift tactics, we move away from trying to equate NDCG across the two interfaces, and instead ask whether we should even fixate on the NDCG for map results. For list results, our observations are in line with those reported in the past. A plot of click-through rate per ranking position in Figure 4 visualizes the decay of user attention for list results, in agreement with established research findings, 6, 15.
Let's go. What
Section
is
3 and 9 describes how this
I think it
monotonic
should be like maybe Nagin's work, huh? Is it no, 15? Is it Expedia? Oh, webcam eye tracking. Okay, they are different studies. I love that people...
decay of user attention is key to the workings of NDCG. But what about map results, where the decay of attention is no longer applicable? Since user attention decay is at the heart of NDCG, the metric is no longer meaningful in the context of maps. In fact, ranking itself is irrelevant for map results, as there is no sequential list involved. To be clear, ranking still plays the crucial role of selecting the top listings for display from all the listings available in the map area. But once the top listings are selected,
to be clear, ranking still plays the crucial role of selecting the top listing for display from all the listings but once the top listings are selected, what that? Okay, but once the top listings are selected, their relative, okay, yes, like I'm on the map, you show me 10 points. Once on the map, their order doesn't matter unless we say, okay, there is a distribution of attention once we look at this two-dimensional screen. Oh, we experimentally validate the hypothesis that ranking doesn't matter for map results. That's why they show the constant curve. Dude, this is amazing. Okay, I love their experimental results. By the way, for our work, we should make it clear what is our experimental setup and everything.
the validation is a simple online A/B experiment where the treatment randomly shuffles the top results for searches originating from the map.
Okay, wait.
The experiment is
So it's
restricted.
the A/B testing. Treatment randomly shuffles the top results for searches. That's very interesting. Originating from the map. Okay, that's amazing. That's kind of A/B test I want to do.
To mobile platforms like iOS Trademark and Android Trademark,
Okay.
where users cannot interact with both list results and map
Okay.
results at the same time.
That's
The case
so
of desk-
beautiful. I love it.
Web browsers, where concurrent access to list results and map results is possible,
Yeah.
will be discussed later in section 6.
Oh, interesting.
From past experiments, we know such a randomization applied to queries from the search box can produce a jaw-dropping booking loss of 8% and degrade NDCG by as much as 5%.
No way. That's interesting. That's a number. That's the number. That's the number I was talking about. So it is not all about the order. So as I said, we are all in the space of decreasing functions because actually that answered my question too. So we are in the space of decreasing functions. So it doesn't matter, however you for short run, for however you sort the list, the one at the top gets the highest attention, highest booking probability, and then decreases. It doesn't matter to the quality of the house, right? So at least for short run, we have decreasing function, but one thing changes. This is the probability of booking, but one thing changes, and it is total probability of booking. Based on your order, the total, because there is one other option too. The user just disengages, leaves the app, quits, is not interested. So it says if you change this order, you still get a decreasing. So, but one thing can tell you which one of these decreasing ones is better. The one that booking rate, well, okay, this is one metric. The booking rate in general, the total booking rate is the most. And it says by change of this, we can have 8% difference in booking rate. total booking rate. And we know that the one that by I think it was Nagim's work or the Expedia's work, that the one that gives you the highest booking rate does not put the best seller, highest quality product on the top, by the way. So probably it's more smooth. If you put the best product on the top, you will have a sharper curve, faster decay. But probably you will have a slower decay. Your general booking rate is more. Very interesting. So it's 8% jaw dropping, degrade in DCG by as much as 5%. What does that mean? From the past experiment, we know such a random example to curve. Where is it? Jaw dropping booking loss and degrade in DCG as much. NDCG decreases 5. Booking decreases 8%. Ah, that's great. Okay.
CG by as much as 5%. The hypothesis is that for map searches, randomization will produce no difference.
That's true.
And this
I
experiment
don't even
indeed
know what
confirmed
it means to have a ranking on map.
the hypothesis. Metrics in treatment are almost identical to control, and more specifically, there is no difference in bookings across treatment and control. This firmly establishes that for searches through the map, ranking the top listings has no effect at all. To show that ranking is irrelevant for map pins, an alternative to the randomization experiment is to plot a rank versus CTR plot for map results, along the lines of figure 4. For map results, we expect the listing ranks to have no connection to user attention, and hence the CTR for each position to be the same, making the plot a straight horizontal line. Instead, we get figure 5. The CTR by ranking position for map results continues to slope down.
I don't know what it is, actually. I don't get that part. What does ranking for the map results mean? Right? We have this point, and we are showing them at the same time. We cannot shuffle them. This place is here, this place is here. Let's ask ChatGPT.
We resolve the mystery of this seeming contradiction in section 7. For now, let's take the hypothesis we proved through the randomization experiment and put it into action.
Okay. So this firm decided that for researchers through the map ranking, the top listing has no effect. Well, okay, the experiment shows that, not the experiment, the observation of human behavior shows that it matters, but our hypothesis results in no change. So our hypotheses are wrong. What does ranking on map Okay, now I have to take a pause. Okay. Just exit Amin, like always, he's down. Thank him. Thank you, Amin. And next weekend, not this one, not tomorrow. Next weekend we are gonna have a podcast. Different kind of podcast. Alright, what is ranking on map? Refers to the process of determining which listing or searches are shown in response to a query and how they are displayed on the map interface. Dude, this is just a bunch of pins. Traditional search results are typically listed in a sequence from the most relevant to the least relevant. It's more like this. Based on a ranking algorithm, however, in a map interface, there is no sequential list. Instead, relevant results are usually written as a pin on a job. Okay, in this context, ranking means selecting the top listings or locations to display on the map. However, unlike list-based results where the exact position to user behavior, where the exact position in a ranked list matters, map results do not involve a visible order. Of course, there is no order. You're saying, what do you mean a visible order? It's just no order. The position of a pin on the map doesn't reflect its rank. Of course, users are likely to choose pins based on proximity to a location of interest rather than the order in which, while ranking still determines which listings are shown. Oh, okay. So you got what happened? I see. It's again kind of the zoom in thing that we were talking about. So you search for a check-in date, check-out date, neighborhood, and what else? How many people? Then they have a lot of results in Airbnb. They have 200, but they cannot show all the 200 on the map. What they can show you is like 15 of them. Those 15, we don't have any order on the map once we show the pins. So our hypothesis were saying that it was not depending, those 15, it does not their click-through rate does not depend. Okay. Like once we are on the 15, yeah, we are on the map, we don't have any order. But you can see that, right? But which 15 we choose matters. Well, of course it matters. What were you thinking? Even also on Airbnb, once you go put your mouse on the pin, it shows you the card. So what do you expect? Of course it matters. So it says, okay, if I show you the top 15, this is the distribution, click-through rate. Well, if I go at the bottom of my list, choose the least popular ones and show you on the pins on the map, of course the click-through rate decreases. But okay, also the list ranking is so low here, it's 8. Okay, I'm not sure if I got it completely, to be honest. Less is more. Wow, this is a big code. Why do we have it here? You mean less results in more click-through rate? Oh, this is good actually. So consider a very simplified view of the probability of booking a listing via given query queue. All listings eligible for the query are sorted by their booking probabilities and the top end selected for display. Okay, we got the map ranking. Thanks ChatGPT. The end top will be shown on the map. We use the following notation: I1 to IN. It's L1 to LN. Listing ranked 1 through N. Probably P attention I, the relative attention received at rank I. Well, all of them should be equal, right? Once they're on the map. P booking L of I, the item L of I. What is the difference between L of I and I? I is just the rank. L of I is the listing rank at the rank I. Probability of booking of LI once seen, the probability of booking for LI once they're seen or before. We write the once they've seen the card or not. We write the probability of a booking a listing via, well, their notation is not very complicated, which is good. Booking a listing via queue using an approach similar to section 5.1 of 12 and section 3 of 9. Booking queue. What is queue? Oh, queue is the query. is probability, the relative attention you put for the rank I, and then you pay this much attention and then you book it by this pro. Makes sense? Number of map clicks, log scale, like 100. Then the y-axis is percent of map clicks covered. Percent of map clickers. What is a clicker? X-axis number of distinct map pins clicks. Oh, you put up to 100? That's stupid. Y-axis. By the way, look at the title. Less is more, but they jumped into the math. They didn't say model. That's very interesting. Y-axis, percent of map clickers covered. 90% of users click less than 12 map pins. Where is it exactly? Oh, like you can see that once it gets to 12, it saturates. More pins does not help. It's just distracting. However, it's still increasing. For least result, probability of attention I is J, for each I less than J. Still I have problem with this part. What is attention? So, like, we have two stages at this search, right? Once is Airbnb. He knows what are the good ones. Okay. Yes. So, okay. Airbnb has sorts these items that match with the query based on their popularity, right? So, your rank is lower, like it's lower, your attention is higher. All right. Then he takes the top 15, top 12 and put them on the map. By the way, my 15 estimate was a good one. I'm so dumb. I was thinking, let's have the podcast tomorrow. Like, I cannot talk. Yeah, let's do it next week. Also, let me add it on my calendar. Saturday, 15. It's also the first day of Hispanic Heritage Month. Perfect. And then ordering the listing by probability of... Oh my god, that's again I'm confused. For list results, this is attention I, attention of the location. Okay, that's the thing. Location has the attention. The product does not have attention. That's very important. We are assuming that the rank by itself has a value, which is true. Ordering the listing by probability of being booked maximizes probability of being booked by Q, which is a greedy algorithm. Booking with the largest user's attention. Disrupting this ordering lowers probability of booking, right? Is that true? Is actually in Amazon we know that it is not the case. In eBay it's not that the case. Maybe in Airbnb we can do it once we are booked this over. Disrupting the ordering booking queue and hence lowers the observed bookings when tested online. Probability of attention I, probability of attention J for each I less than J. So attention is a decreasing function. was true for map results as well. Matching of probability of booking with probability of attention would be suboptimal in the randomized experiment, causing to drop, resulting in a bookings loss for the treatment. But since bookings did not drop in the randomization experiment, booking did not drop. Dude, I'm so confused, to be honest. The property must be false for map results. Alright. Said the following must hold: probability of attention for I is equal to J for each ij. Yeah, okay, that's what matches our hypothesis. To represent that user attention is distributed equally across the top listing displayed as map pins, we assign probability 1 over n, which transforms equal 1. Yes. Property 1. The probability of booking a listing from a map result is given by the average booking probability. Alright. That sounds good.
Given that listings with the highest booking probabilities are selected as map pins, and because of property 1, the lower the number of pins, the higher the average booking probability. This leads to the less is more principle of map results. The lesser the number of pins shown, the more the bookings. Applied by itself, the less is more principle drives down the number of pins towards the degenerate case of a pin on the map. Given that listings with the highest booking probabilities are selected as map pins, and because of property 1, the lower the number of pins, the higher the average booking probability.
Yes.
This leads to...
That is actually not true, right? If it was all 1 over n, then you just wanted to have the Li with the highest probability and show it to them. Well, we can say, okay, it's not practical to, but it says, okay, so that's not true. At least we can say 5 is better than 12, right? But it says, actually, not 1, but 5 is better than 12, by this mindset.
The less is more principle of map results, the lesser the number of pins shown, the more the bookings. Applied by itself, the less is more principle drives down the number of pins towards the degenerate case of a single pin on the map, as that maximizes the average booking probability. So our simplistic view needs a counterbalance which recognizes that users often click through multiple pins.
Yeah.
Figure 6 shows the distribution of the number of distinct pins clicked by searchers.
Figure 6. So somewhere between 12, right?
A 95% coverage suggests around 12 pins. This indicates the optimal user experience requires much fewer than 18 pins, the fixed number of pins in use for years. While the arguments above suggest that lowering
all of these numbers are interesting. Like they used to, it's just history of the company, by the way. They used to do 18 pins, but it's not the good number. But it was pretty good actually.
The number of pins below 18 might improve user experience. They leave the important question unanswered, that is, how to determine the optimal number of pins for a particular map result. Intuitively, to construct a map result we start with the listing that has the highest booking probability, and hence must always be shown on the map. If subsequent listings have comparable booking probabilities, then adding them as map pins provides the user with choice, without degrading the average booking probability too much. However, if booking probabilities of the listings that follow drop significantly, then adding such pins only increases the chance of the user exhausting their attention on such pins and leaving without booking.
These
We
are
put this
also,
intuition
all of
into
them are
action.
something intuitive. They don't show any proof for them, which I say that's actually the way to go.
In algorithm 1, which we refer to as the bookability filter, given two listings and their corresponding ranking model outputs, and are related to the booking probabilities by equation 3.
We need to go over that.
An in-depth discussion of equation 3 can be found in section 2 of 9.
Logit. Given two listings, LX and LY, their corresponding ranking model output, logit. Ranking model output, alright. Logit LX and logit LY, it's their ranking, are related to the booking probabilities by equation 3. Where is the equation 3? Oh, it's here. An in-depth discussion of equation 3 can be found in section 2 of 9. Okay, section 2 of 9, okay. Logit of LX, rank of LX minus rank of LY. What is LY? Why is LY so familiar to me? Is log of booking of LX over probability of booking LY. So that should be this. This is something very strange. This is some assumption you said. It is convenient. So this is an equation that holds in theory, I guess. It cannot be all the time. It is convenient to specify the filtering condition in terms of the logit, since they are, because the right hand side is something by your observation of users' behavior, and the left hand sides are just numbers. Okay. No, it's okay. So we can have right hand side by observation from user behavior. What are the odds of you being booked as a, what is it called, as a listing? Then all those probabilities give, well, okay, that's actually there is no difference. So you're just saying log of this is log of this minus log of this. Fuck that. So log of Lx is kind of log of probability of booking of logit of Lx is log of probability of booking of Lx. That's all right. It isn't, and then you arc sort it to give you their rank. It is convenient to specify the filtering condition in terms of the, since they are directly available as outputs of the ranking. So bookability filter. LY. What is LY? I don't remember. Actually, they just jump into the experimental results. That is amazing. Which I like, actually. And then maybe after experimental results you come up with more theory. That's great. What's going on here? So bookability filter, a set of T listings. Okay, it used to be N, now it's T. Filter parameter alpha, output a set of N. Okay, so we have T, we want to choose N out of those T. L1 to Ln. L max is argmax, and K. Okay, this is the threshold. Then L of output. Okay, we are comparing everything to the maximum one. All right, everything compared to the maximum one, not the ones next to each other. And if this happens, you add LK to the output. And it makes sense. This is a very simple algorithm. Just for so a ball around the K, but by the minimum of also, so minimum of N and also your probability. For an intuitive understanding of the condition on line 4, dude, it is so simple. There is no intuition. Algorithm needs for intuition 1, we rewrite its user. Option 3 as bullshit. Yeah, actually, it is not intuitive at all. All right. The bookability filter admits a listing as a map greater than this, the smaller the value of alpha. It's the radius, so we need to fewer the number of pins on the map. Hence, the higher their average booking value, but lower the number of choice available. Makes the number of map pins dynamic and fine-tuned for each map result, taking into account the probabilities of the listing at the end. There is actually, that's very, like, comparing to what we want to do, the three-dimensional case. Yeah, we want to have these parameters that we want to plot the stuff based on them and then take action based on our observation. Where map pins, I have better understanding of what I want to do. I should not take my project too theoretical. Like the mechanism design thing, good. It's a good setup, but not great to solve it mathematically. Account the booking probability the lesson. There is no simple analytic way to infer the optimal value of alpha that balances both the average book and choice. Therefore, we shift determine online experiments. Great. Nothing beats experience. Dimitris Konomis. Why doesn't it say which page we are? Well, let's say 3. Now I want to see how much time.
In the first phase, we study the effects of the parameter through offline simulation of the search system. Table 1 summarizes the aggregate statistics of
Table 1, where is table 1? Okay. Alpha, number of map pins. Alpha 1, 2, 3. So bigger the alpha means more pins, because unless n limits it. Reduces average booking probability. For alpha 1 is 47, then we can see that, yeah, because we have more, it decreases, the average decreases. Average total price, but it cannot decrease a lot because alpha controls that too. Average total price, what is that? An average number of reviewers decreases. Why? I don't get them. Average reviewing rate. So this one is like this. When there is very small, they don't review. then increases, and then decreases. Offline exploration, so there is a trade-off between choice and quality. Offline exploration of alpha compared against the baseline with no filtering, which is conceptually infinite. Oh, alpha infinite, yeah. Oh, you are comparing with alpha infinite? When we show all of them. Okay.
Map results corresponding to different values of. The lower bound of the exploration is set by product experience considerations, and the upper bound by the result of diminishing effects. The baseline for all these comparisons is map results with no filtering and a fixed limit of 18 pins. Table 1 validates that the bookability filter is having the intended effect on map results. The second phase of our testing investigates how users react to various values of. We run multiple A/B experiments online, where control applies no filtering on map results, and
treatments apply the bookability filter with different values of T. Table 2 summarizes the effect of time on searchers. A brief explanation of the key.
Table 2, alpha, and exploring alpha through online A/B experiment, uncancelled bookings. Uncancelled bookings. What do you mean uncancelled? The ones that were not cancelled. So you keep the quality high, the bookings uncancelled more, better. 5-star trips decreasing for sure. Average impressions to discovery, what does that mean? That increases. Average click to discovery increases. They click more. Alright.
treatments apply the bookability filter with different values of.
T. Table 2.
That's one fix they should do for ChatGPT. Started from.
Table 2 summarized 5-star uncancelled bookings. This is the top line metric, the number of bookings made by searchers that were not cancelled. 5-star trips booked by searchers that resulted in a 5-star rating after checkout, evaluated 120 days after the end of the experiment. Average impressions to discovery, the average number of distinct search results that a booker saw before clicking the listing that was booked. This measures the cognitive load of making a booking. Average clicks to discovery, the number of distinct search results clicked by a booker before clicking the listing that was booked. This is an alternative measure of the cognitive load of making a booking.
The average number of distinct search results clicked by a booker before clicking. Ooh, okay. I was saying completely different. Cognitive load making a booking. Ah, what a nice term. Cognitive load. I like this term. Let me add it. Where is it? So eyeballing cost and articulation cost, cognitive load. Where is it? Morning. That's a nice term. I think it's cognitive load. We cannot charge consumers for that, but we cannot give them headache too. Okay, good to know. You have me, yeah. So average impression to discovery, what is it? Average clicks to discovery, how long does it take to find it? Cognitive load, that's a good one. That's very nice. The average number of distinct search results that a booker saw before clicking. That's also very good. Uncancel. These are nice research actually. These are beautiful research. You get better understanding of human being.
In the final phase, we fix the value up to 1.0, corresponding to maximum user benefit, and repeat the online A/B experiment at a larger scale, allocating 34 million searchers worldwide to each of control and treatment.
That's amazing, dude.
This grinds the p-value of the key
What
metrics
are the
below 1.0.
experiments? I love this
Uncancelled
kind of-
bookings increased by 1.9%.
Fuck off, dude. If the highest experiment is letting a tiger and lion fight, which is this has been done. This is immoral and unethical. Okay, the highest experiment is leaving a lot of tigers for a long period of time in Saharas and Africa and see if they start living in prides, or taking lions to the jungles and see if they start living like tigers in small, like solo. Then this is the experiment they are doing. They are doing experiments on people. Well, that's like not people. I don't think there is anything unethical. They are trying to build solutions that consumers like more. So, but the crazy thing is that they are running the experiment on 34 million people. That's crazy.
As a percentage of overall, in the final phase, we fix the value up to 1.0, corresponding to maximum user benefit, and repeat the online A/B experiment at a larger scale, allocating 34 million searchers worldwide to each of control and treatment. This grinds the p-value of the key metrics below 1.0. Uncancelled bookings increased by 1.9%, measured as a percentage of overall global bookings at Airbnb, making it one of the largest improvements launched over the last several years. 5-star trips increased by 2%, indicating not only growth in bookings but also growth in quality bookings.
See?
The average number of results seen by the searcher before clicking on
They increased the 5-star trips by 2%. Like, people are having more better trips by 2%.
the book listing reduces by 16%, while search results click drop by 6.8%. The reduction in effort to locate the book listing, due to the removal of inferior choices, is the key mechanism driving the gain in bookings.
It is crazy, dude. It is crazy that you can help other people enjoy a better trips. That's amazing. Okay, however, we don't know if this is just the cause of it. Fuck, we did this and the results changed like this. I don't get too much. Making it robust. So figure 7 says total listing ranked and rank of anchor booking probability. What is anchor booking probability? X-axis number of x-axis number of total listing ranked, listing length. Y-axis is rank of the listing supplying the anchor booking probability tuned through empirical evaluation. I don't understand. So it's something increasing. But okay, where was the mathematics, however? Honestly, I feel all mathematicians should start, like applied mathematicians, should start reading this kind of papers because they are giving them through data how life is going. This was actually the missing part from my research. This kind of papers. Maybe after one of these kind of papers, we come up with a theoretical model. I love that. This breaks the mental masturbation cycle. This breaks the mental masturbation cycle.
The bookability filter puts a lot of faith in the booking probability of the topmost listing, denoted as, in inequality 4. We refer to it as the anchor booking probability.
Okay, the bookability filter puts a lot of faith in the booking probability of the topmost listing. Yes, denoted as Almax, inequality 4. Yes, when we say all of them should be radius of like alpha of the anchor booking probability. Anchor booking probability is the Lmax. Alright, so total listing rank of anchor booking probability. So if we have more than, like, if T is greater than 2048, the Lmax is very high probability, which is interesting because the sum of them should 1. Total listing rank. Very interesting. So the more listing we have, the probability of the top one increases. What?
At times, the anchor booking probability may be an outlier. An abnormally high anchor booking probability can make it difficult for the rest of the listings to pass through the bookability filter, limiting the choice of listings and making searchers quit prematurely. Gathering insights by debugging a few such cases, we test a more robust way to compute the anchor booking probability by considering the average of the top 3 listings instead of relying on the topmost listing alone.
Yes, I agree.
Since the median is more resilient to outliers than averages, we further fortify the anchor booking probability to be the median of the top 3 listings. This shifts the anchor booking probability from the topmost listing to the second highest listing.
That's very smart, I agree. All right. And now we are going to the experimental results. Oh, focus versus urgency. What a beautiful topic. Like how patient you are. Dude, we are on page 4. This is a kind of a paper you want to write and read. Honestly, reading it is exciting. You are gaining knowledge. Some people didn't. Well, the thing is that we cannot replicate this kind of experiments. But still, if you trust them, which is a big thing.
The online A/B test for improving robustness applies filtering with fixed at 1.0 for both control and treatment map searches. The difference is that in control,
okay, we cannot
the topmost
replicate
listing,
it, but still, they are sharing it with us, and if they are honest, they are giving us a lot of good intuitions. So, it should be nicer that we are in contact with these people, and they are in contact with us. Because there's no way we cannot replicate. We don't have 10 Airbnb so that every one of us go and try it.
supplies the anchor booking probability. The online A/B test for improving robustness applies filtering with fixed at 1.0 for both control and treatment map searches. The difference is that in control, the topmost listing supplies the anchor booking probability, while in treatment, it is the second listing from the top. This increases the number of map pins in treatment by 6% compared to control, indicating a milder filtering. Searchers to listing viewers conversion improves by 0.15% with a p-value less than 10, with no negative effects on any of the other metrics. The increase in searchers continuing their journey shows that correcting for outliers moderates the cases where filtering was restricting choice for searchers. Inspired by the success of this experiment, we do one final iteration. Instead of fixing the anchor booking probability to the second highest listing, we make it dependent on the total number of listings in the map area. The reasoning is that the larger the number of listings rank.
Inspired by the success of this experiment, we do one final iteration. Instead of fixing the anchor booking probability to the second highest listing, depending on the total number of listings in the map area. Why? The reasoning is that the larger the number of listings, like through the paper, they are changing their metric. That's interesting because it is how you run an experiment and then you play with it. And I like that they are reflecting in their paper. The reason is that the larger the number of listing rank, the higher the chances of getting hit by outlier. Okay, the bigger, yeah, you can see that was increasing. A plot of the rank of anchor booking is in figure 7. Alright, we looked at number of map pins by 2. But how do they change it? It's not 7.
Ranked, the higher the chances of getting hit by outliers.
Okay.
A plot of the rank of anchor
okay.
booking probability as a function of the total listings ranked is shown in figure 7.
256,
This further
is
increases the number of map
highest.
pins by
Between
2.6%
this
without
and
degrading any
1024,
metrics,
third
thus
highest.
balancing between
now it makes
optimizing
sense.
average booking
Fourth highest
probability
and
and
fifth
providing as many choices as possible.
Alright. Very interesting. I'm understanding this paper. We are talking here. Focus versus urgency. Yeah, mood of the customer. Wait a second, we just had an experimental result title. Right? Yeah, oh, for each section, right? They have section 4. Oh, for each section they have an experimental result. Oh, very nice. Oh, you just noticed it now. This is such an amazing paper. So, every theory part or everything every hypothetical part that we come with, they have an experimental result that confirms or unvalidate. What is the opposite of confirm? Negates, contradicts their hypothetical models. This is so pretty. I love it. So every section has a section 5.1, 5.2 is the experimental.
The blockbuster results of Section 3.1 call for celebration, but they also raise some eyebrows in the room, questioning the cause behind such a significant booking gain.
Wait, what?
While we can see user
The blockbuster result of Section 3.1 calls for celebration. Section 3.1, what was it? Less is more? Yes. Alright. But they also raised some eyebrows in the room, questioning the cause behind such a humongous booking gain. What was 6%? While we can see users clicking less to discover the book listing. Yes, the load, it decreases the load and they find it. So user is having a better experience on the platform, and also in 120 days they find a better place. They leave more 5-star. Booking increases, the metrics don't communicate what the user are experiencing. I see. The optimistic theory is that restricting the map pins is directing the user's attention to the most viable choices, reducing distraction, so the cognitive load decreases. So users are experiencing focus. This would mean we are on track for the celebration. Very interesting.
clicking less to discover the booked listing, and overall bookings increasing. The metrics
Dude,
don't
this
fully
kind of
communicate
studies
what the users are actually experiencing.
Change economics forever.
Actually experiencing. The optimistic theory is that restricting the map pins is directing the user's attention to the most viable choices, reducing distraction. In this scenario, users are experiencing focus, meaning we are on track for celebration. The alternative theory is that restricting the number of pins is making users feel that not many choices are left for them to book, and what they're experiencing is urgency. This would be enough to cancel the party. The trouble is, how do we tell apart the two possibilities?
Wait a second, what is the other option? Theory. The optimistic one is that users are the two most viable choices, and reducing distraction, less numbers. Focus, meaning we are on track for celebration. Alright. I think both happen. That's the thing. You are more focused, you are enjoying usage. We have different kind of consumers. I think that's it. That's out of control of platform. And these algorithms favors one of these kind of consumers more. Maybe on Airbnb you say people are less urgent, huh? The alternative theory is that restricting the number of pins, and I love that. The trouble is, how do we tell apart the two possibilities? I think that both possibilities are possible and are happening, and different consumers react differently. So Airbnb has to kind of find out which kind of consumer they are serving at the moment. Is that restricting the number of pins is making users feel that not many choices are left for them to book. What they're experiencing is urgency. Cancel the party. And then they have experimental result for it. Tired user retention. This was an amazing study. This is an amazing study. One click counter, so bad. One thing that I feel is missing, well, we should not have it in this paper, is that, okay, we have these data. Now let's come up with a user behavior model. You know, we have this data, let's come up with a model for user behavior for our next studies. But as I said, it should be a result of another paper, not this paper.
We answer the riddle through an online experiment. Let's walk through an example map result to understand the experiment design. Suppose there are 1,000 listings available in a map area. After ranking these 1,000 listings by their booking probability, the baseline algorithm picks the top 18 to show as map pins.
Okay.
Consider the case where the bookability filter restricts the number of pins to 14, leading to a booking gain. The urgency hypothesis is that reducing the number of pins from 18 to 14 makes the user panic, driving the booking increase. The focus hypothesis is that users have a much higher chance of discovering a bookable listing among the 14 when compared to sifting through 18. The test to differentiate between the two hypotheses is as follows. Control, show 18 map pins. Treatment 1, restrict the map pins to 14, selecting based on the highest booking probabilities from the baseline 18. Treatment 2.
Treatment 1, restrict the map pins to 14, selecting based on the highest booking probability from. Okay, treatment 2.
Restrict the map pins to 14, same number as treatment 1, but select randomly from the.
Treatment 1 chooses the good ones, treatment 2 just chooses the randomly, or choose the bad ones actually.
Leave from the baseline 18. Both treatment 1 and treatment 2 reduce the number of pins, but their average booking probability of map pins differs. The possible outcomes of this test are.
So if it was focus based, treatment 1 should be nicer. I don't know. Like I feel focus correlates with treatment 1 more, and urgency shows itself more in treatment 2, right? And I like that they're just assuming two assumptions. They could have more treatments, but they said no, we are gonna choose this. I love this. We decided this is our paper. We are not proving anything.
Urgency fully responsible for booking gain. If urgency causes the booking gain, users will feel the same urgency in treatment 2. Both treatment 1 and treatment 2 will show the same booking gain over control. Urgency partially responsible. If urgency partly explains the gain in treatment 1, a similar, but smaller, gain will be seen in treatment 2. Treatment 2 will have a positive gain over control, but smaller than in treatment 1. Urgency not responsible. If urgency has no role, bookings in treatment 2 will be equal to or lower than control, with the difference driven by listing quality alone. The verdict from the online A/B test is clear: urgency is not responsible for the booking gain.
Actually, I'm so happy I read this paper. Now I can come up with a better proposal. Let me say, we do these experiments. We do these experiments.
Bookings in treatment 2 dropped by 1.5% compared to control, with a p-value below 1.0, confirming that the gain in treatment 1 was due to focus, not urgency.
Urgency is not responsible for the booking gain. What is p-value, by the way? Okay.
A p-value is a statistical measure used to determine the significance of the results in a hypothesis test. It helps quantify the probability of observing the data, or something more extreme, if the null hypothesis is true. The null hypothesis is typically a statement that there is no effect or no difference between groups being compared. A low p-value, usually less than 0.05, suggests that the observed data is unlikely under the null hypothesis, leading to its rejection. This means the results are considered statistically significant, and there may be evidence for the alternative hypothesis, the effect or difference exists. A high p-value, greater than 0.05, indicates that the observed data is consistent with the null hypothesis, and there's no strong evidence to reject it. This suggests that any observed effect could be due to chance. For example, if a p-value is 0.01, it means there is a 1% chance of observing the results, or more extreme, if the null hypothesis is true. In your experiment, a p-value below 1.0 means the likelihood of the observed result occurring by chance is extremely small, providing strong evidence that the effect is real.
What effect is real? I think what effect is real in my case? The focus. What is the null hypothesis?
The null hypothesis is a statement used in statistical testing that assumes there is no effect, no relationship, or no difference between groups or variables being tested. It represents the default or status quo assumption in a hypothesis test. In simple terms, the null hypothesis asserts that any observed differences in the data are due to random chance and not due to a real effect or treatment. The goal of hypothesis testing is to determine whether the data provides sufficient evidence to reject the null hypothesis in favor of an alternative hypothesis. For example, in an A/B test, the null hypothesis might state that there is no difference in booking rates between the control group and the treatment group. In a drug trial, the null hypothesis could be the new drug has no effect on patients compared to a placebo. When performing a hypothesis test, if the data shows that the observed result is very unlikely under the null hypothesis, indicated by a low p-value, the null hypothesis can be rejected, suggesting that there is an effect or difference.
So when the p-value is low, which is the probability of the null hypothesis, it means that it has no effect, right? Urgency has no effect. Perfect. Did we read this section? Yes. Tired. Tier. Yeah. This is not tired. This is tiered user attention. What is a tiered user attention? So nothing about zoom in gain, by the way. Let's take a look at the figure 8 and 9. Map result with mix of regular pins and mini pins. Oh, it's about zooming in. And then it's on the screen, card and map presentation. Alright, perfect. Tiered user attention, alright.
When using Airbnb search on web browsers, the results are laid out as a grid of listing cards on the left. On the right, the results are displayed on a map, figure 8. Consistency of product experience demands that all the listings shown in the grid, in total 18, must have a corresponding pin on the map. Lowering the number of map pins is not applicable in this scenario. We adapt the insights from section 3 to the constraints imposed by desktop browsers by creating 2 tiers of pins. In addition to the ovals with price, we create
click-through rate for the mini pins is 8 times less than the regular one.
a smaller oval pin without the price display. We refer to them as mini pins.
4
Figure 9 depicts a map result with regular pins and mini
and
pins.
6 mini pins.
The mini pins draw less user attention by design.
There are 8.
Click-through rates for mini pins are 8 times less than regular map pins. Differentiating the pins into 2 tiers allows us to write, in equation 1 as
highest booking probability are assigned regular pins on desktop browser, but lower booking are assigned mini. User attention towards listening also. Experimental results. Interesting.
We test the idea through an online A/B experiment where control displays all 18 listings from the list result as regular pins on the desktop map. Treatment applies the bookability filter to assign listings satisfying inequality 4 as regular map pins. The remaining listings from the list result are assigned mini pins. The results in table 3 show the effectiveness of tiered user attention.
Uncancelled booking increased, 5-star trips increased, average impressions to discovery decreased, which is good. They found what they wanted faster. Average click to discovery decreased, which is good. Cognitive load decreased. Everything is good. So tiering actually works. Categorization helps. How attention flows on maps. So we have good reasons to follow the categorization idea because it brings the cognitive load low. How attention flows on maps. Ah, that's great. They have it. From center, it's like a ball actually. All right. Dude, what an study. What an amazing study. This is an amazing study. And our study will be amazing too. Dude, this is crazy. We can compare all of these models, presentation models and metrics. Oh, shoot. How do they study that? Oh, they have the mouse pattern. Oh shoot, that's actually a big section. My cognitive load is collapsing. Alright, actually it should. We will keep the section 7 for the next time because of doing a good job. Dude, this was such a nice paper. This is actually, we haven't done it. But because we did a good job, I really like the paper. Wow. Simple too. Let's do 2 rounds. Like always. One warm up, 2 rounds. And I earned it. Oh should we actually watch?
Let's roll.
Thanks to ChatGPT, by the way. Oh wait a second, here. I said to run one warm up, but one of our warm up is actually a full set. So, do you think I will measure it as a warm up? Yes, you're right. I will. Get into your face, bitch. Another one of you whores. Oh. Now he's killing him. Oh shoot! Who's there? Anyways, I'm the winner. Where are you, Mom? Move. Because this fucking guy is happening. Oh shoot. Dude, why didn't he shoot? That was so scary. Dude, bitch. Lucky me, honestly. I didn't want to be killed again here. Hahaha. But oh shit. Took something out of me, motherfucker. Huh? I didn't know bot can come after you. Is it only me? Is it all bots? No, it's me. Yeah, it's okay. Who's shooting me? Where are they? Where are these fucking hoes? Where are you going? Ha ha ha. Ha ha ha. Lulu. I killed you good. I killed you again. I killed you again and a lot. I am escaping here. I am escaping here. Ah, shit. Ah, don't kill it. Ah, don't kill it. Dude, just make them weak and I will kill. Who are we having here? Is there anybody here? Oof! Killed you. Oh shit. Dude, these fucking bodies that has my gun, which is funny. Where are they? Dude, you got this. You like this game. They're all here, but where are you, bitch? How could you kill me? Yeah, I was half. Zenus, where are you? Coming. Oh, you killed him. No, 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 no. That was so terrible. Oh. That was fast. Dude, I'm just headshotting. Who is shooting me? Somebody has better gun than me. Two of them. Alright, bitch. Didn't I kill him? I did kill him. Come on, their gun is better than mine. Where is the shooting happening? Oh shit, that was so harsh on me. Everybody, this is a dude. Actually, we should make a match. Everybody have this gun. Oof. And then just close distance shooting. That was like 5 of us. Ooh, shoot. Cheers. Okay, oh shit, I'm the sniper. Ah shit, 3 people. Come here, bitch. I'm coming. Here. That was my warm-up. Okay. Yeah, that was my warm up. I should talk louder. I'm sorry. Let me kill them more. Actually, he's a smart. Dude, give me some room. That was so weird. Ooh, shit. Kill you. How can we get you? Dude, this guy's killing me so fast. Fuck. It's fucking bad. I don't let you kill my gun. You go jump with your fucking. This is fun. This is fun too. This is fun too. This Phoenix guy is just on the snipe. Who knifed? Wow, that knifer just... Aminorius. I thought it was me. He was just knifing. I killed more? Wait, how? I killed more. He won't first. Does knifing in a row increases? Water. Oh shit, we're back here. It won't be no fun. This motherfucker is going just for them. Do you think Aminorius can knife everybody this time too? Aminorius, I'm behind you. Hopefully I won't let you any kill. Where are you, motherfucker? Where are they? Wait, you moved to another city? That hurts. Honestly, that hurts. Fucking bitch. You think you're anybody? Oh, again? From back? You fucking hit. Don't let them breathe. Oh shit, Aminorius, look at him. He's just knife. Wait, his knife is stronger than ours. Oh shit, what will stun is... Oh, look at Aminorius. Alright, maybe we should knife too. Alright, Aminorius has his own game. You better chill the fuck down. Because Bot Voltzman is killing me. And I don't like it anymore. bitch. Oh shit. Ah, fuck you, Wolfsman. Ruined my feast. Oh, he's Aminorius. Oh shit. New member. I don't like it. Oh, he's Aminorius. Aminorius pulled the gun out, finally. Oh, that's why you use knife, because you don't know how to use your gun. Dude, they made Wolfsman. Whoever fucks me, his name is Wolfsman. That's, I know, it's just a mental warfare shit you're playing. And I don't like it. Of course Kev kills me. Shit. Fucking host. Dude, those, finally. Okay. Did you see that? Oh shit, he's alive. Bitch. Where is the next one? Oh shit. Fuck dude. I couldn't see my green. The pointer. Where are you, host? Ah, fuck. Alright, no. Let's go baggage. I said 2, but let's go baggage. Actually, baggage wins. Yeah. Why did she leave? Oh, somebody else left too? Oh, okay. It was too easy for Aminorius. Last one. Where are these people? I miss you. Where are you? So it's just me and Xenex. What are you doing? That was it? Bitch. Where is this going? That's actually very interesting. Let's go here and kill this. No, don't kill me now. I need some blood. My blood. Oh, Ants is back. Alright, let's go. Shit, this motherfucker is hiding there. Where's the loot? Oh, headshot. That was a nice shot. Bitches. Let's go upstairs. What if I jump on him? Didn't I kill him? We don't have jumping on each other. Dropped you. Okay. Wow, why? I thought I did better. Dude, I got the same gun. What's happening, dude? Fucking ghost. Dude, I killed him. Alright. I should have jumped. I should have jumped. Can't jump when I got instinct locked in a house. Oh, shit doesn't give you the second. Ooh. I have to find a safe place, otherwise. Did you see that? You need somebody who is already dying. And you just want to headshot them. Like this one. Shit. Alright, keys. Now I cannot even jump. Bruh. I'm fucking I received 2 bullets and I didn't die. That was funny. Alright. I think we are addicted to this path, which is path of success. Where are you, host? No. That was too far. What are we doing? Oh shit. Surroundings. They always have better hand there. I don't know. Actually, I want to go to the open space. Some balls action. Some ballsy action. I've never been here. Oh shit, fuck you ants. Do you think you can sit down and enjoy? Call me after you. What happened? That wasn't fair. There's not a lot over there. Somebody got the pistol. Shit. Hans is above. Alright, take the game seriously now. Break is over. Where are they? I cannot find them anymore. Dude, come on. I could have both of them. Sometimes if you don't kill them like this, they think it's just a normal thing. They don't die. Fucking chickens. Here's the place to change and recover. Because, oh shit, if I had it, I would kill it. I think this is the place that you go regarding your gun, you go. Fucking ants. Where are we going? Not Reagan. She has the fucking knife. Finally. Yeah. And jump here, I got instinct. Yeah, bitch. Yes, fuck you, ants. That was the best game ever. Alright. Time to leave. Ah, I didn't put you in the thing. Okay, fuck it. Sorry, my bad. Yeah, you watched it this month. My bad. Next time I will. And we will come back, finish the paper. I want to finish the paper for today. For today. And that's it.